Training AI is often complex, coding, infrastructure, huge costs. With Trainlab.ai, anyone can train models, validate datasets, and deploy in minutes. Let's get started. Here you can create your first data source, explore ready-made blueprints, or get help when needed. And with our quick start guide, it's simple. Upload data, configure your model, train and test, then deploy, all in just a few clicks. Let's create our first data source. Give your data source a name, add a short description, and select the domain it belongs to. Trainlab suggests the right task with a quick questionnaire. We select images as our data and choose to sort them into categories. The system automatically maps it to the right AI task, no guesswork needed. Now, let's choose a data source. You can upload a file, connect to external storage, or use the annotation lab. Here, we'll upload a file directly. Let's upload our training and validation files. You can simply drag and drop a zip file containing your dataset, and Trainlab will automatically process and prepare it for use. Now we map our dataset fields. Just drag and drop from the available fields on the right into the required areas on the left. For image classification, we map the image file to the input field and the category to the label field. Once mapped, Trainlab is ready to validate and prepare the data for training. The final dataset is now mapped and validated. Trainlab shows a sample of records so you can review before training. Here we see a total of 4,388 and 624 valid samples across two classes, normal and pneumonia. The system also highlights warnings, like class imbalance, and suggests fixes, such as data augmentation. By catching errors and quality issues early, Trainlab ensures the model is trained on reliable data. This is the final step of data source setup. With encryption complete, your data is fully protected and ready for model training. Now that our data source is ready, let's move into fine-tuning. Enter a model name, add a description, and select your data source from the drop-down to begin fine-tuning. Select your training mode. We'll go with base model training for quick and reliable results. Now we choose a model for our task. Trainlab supports a wide range of models. It's not restricted to any one type. For this demo, we'll select Google's base model, which has no prior knowledge of our use case. Next, we select the efficiency mode. You can choose Enterprise, Efficient, or Ultra Efficient. For this demo, we'll go with Efficient mode. This is the most important step, and often the reason training fails. But don't worry, Trainlab's smart AI system automatically calculates the optimal hyperparameters for you. This training will finish in about 45 to 60 minutes, costing between $7 and $15, with no hidden costs. Our smart AI assistant keeps you updated throughout training. Here, it shows the model is healthy, meaning everything is learning perfectly and progressing smoothly. It also provides recommendations, like reporting excellent progress with training loss reduced by 69% and validation loss down by 33%. Key metrics such as progress, current losses, and best performance are tracked in real time. The training matrix gives a complete view of your model's performance. Here you can track training metrics, monitor changes over time, and review evaluation metrics as they evolve. It also highlights overall training performance, so you always know how efficiently your model is learning. Our model training is now complete. You can download it directly from the download section and start using it right away. Now, let's deploy with one click. Trainlab publishes the model behind a secure API gateway with API key authentication, rate limiting, and access control, plus built-in analytics for requests, latency, errors, and usage trends. Let's test it in the playground. I'll upload a chest X-ray with pneumonia and run the model. The prediction appears instantly with confidence, along with latency and response details. We can see the model clearly identified pneumonia with a confidence score of 0.99. Now, let's try another image, this time a normal chest X-ray. The model predicts normal with high confidence.